Okay, last concept in chapter 7, slope dummy variables. I've already shown you from a previous chapter. Now, I was horribly tempted to raise this issue back then. I'm not real sure why he raises dummy variables as early as he does in the book, and then actually finishes the concept not until chapter 7. But anyway, I'm sure, since this is the 7th edition of the book, I'm sure he's thought about it a lot, and he has a good reason for it. All right, I showed you earlier something like this. I can't remember exactly what it was now, but let's see. Do it this way. I don't like to write gender, because gender, you're like, oh, well, is it a 1 for a male or a 0 for female, or 1 for female and 0? I like to write so that your intuition as the person looking at the regression is, oh, you must have used 1 for female and 0 for male. You're not going to write male. Oh, you used 1 for male and 0 for female. So that's what. Normally people just write the word gender, but I don't like that, because then you got to look through the article to figure out, whoa, what's the 1 and what's the 0. I wrote that kind of small. Is that legible? Yes. Although it could have been a little larger. Sorry. Okay, let's say you run this regression here on teacher salaries, or salaries anywhere, for crying out loud. And you figure that someone's salary is a function of how many years they've worked in this industry. And you also believe there may be some discrimination in either direction. It doesn't matter. In fact, this might be a case where you don't have a hypothesis for beta sub 2. It could be a two-sided test. Although, generally speaking, I believe that in using female as 1 and male as 0, you'd be expecting a negative coefficient here. Okay, so that means, if you estimated it this way, let me make sure I leave myself enough room here. I'll draw this one over here. It's a wonderful cup given out by the School of Interdisciplinary. It has its own built-in coaster. I love this cup. All right. If you run this regression, what you're assuming is that there's a kind of once and for all boost. Let's assume we believe that beta sub 2 is going to be negative. A once and for all increase in your salary if you're male. When you run this regression, yeah, we'll do it that way. No, let's do it that way. Okay. And this is going to be beta sub 0. I'm just going to write male here. So if you run this regression, for every male observation, that's a 0, right? So you end up with the intercept being, the slope is the same whether you're male or female. It's still beta sub 1. But the intercept is beta sub 0 if you're male, and it's beta sub 0 plus beta sub 2, which we're assuming is a negative number if you're female. Beta sub 0 plus beta sub 2. All right, yeah, beta sub 0 plus beta sub 2 if you're female. Now, what if you believe, though, notice here, it doesn't matter whether you're a new hire or whether you've been working here for years. The difference is still the same. What if you believe that instead, what's really going on here is that they're rewarded differently over time? Perhaps there's an incoming salary that everyone is hired at, and so there's not going to be a difference on the intercept here. When years is 0, it's going to be the same back here. But you believe that over time, the men are singled out for promotions and so forth in a way that women are not. Then you need a slope dummy variable. This is an intercept dummy. This dummy variable that we covered in an earlier chapter changes the intercept. But we keep the slope the same. We figure that a year of experience rewards a female or a male employee at the same rate. But you may believe that instead, no, actually, there's a starting salary that everyone gets. But it seems that like 20 years into this company, 10, 20 years in, the men are all making more money than the women. So I believe that the difference is how they're rewarded over time. Then this regression is not going to capture that. All right, let me give you another regression here that I'm going to write in orange. Salary is equal to beta sub 0 plus beta sub 1 years plus beta sub 2 female times years plus the stochastic error term. Okay, now I have a slope dummy, which is what this chapter is talking about. Now I have a slope dummy instead of an intercept dummy. Let's see what I got there. Yeah, okay. Instead of an intercept dummy. All right, and so what's that going to look like? What's that going to look like instead of what we've already got? Let me draw this in a horrific color, Baylor green. Years, salary. Now we're assuming they both have the same intercept. So that's beta sub 0 in both of them. Maybe I should have noted that over here. Let's see, these slopes are both beta sub 1. Both of those are beta sub 1. Over here, they're both going to have the same intercept. But if you're male, the intercept is what? I'm sorry, the slope is what? I'll fill that in just a second while you're thinking about it. What's the slope for a male employee? Beta sub 1. Now, what's the slope for a female employee? And I'll show you the math here in just a second, but let me jump here to it's beta sub 1 plus beta sub 2, and we're assuming beta sub 2 is a negative number, all right? So it's a lower slope. Because what do you get in this regression when you have a male observation? You get 0 times years. So this term falls out completely. What do you get when you have a female observation? You get beta sub 1 years plus beta sub 2 years, because that's a 1. For a female observation, that's a 1. So this part of the equation becomes beta sub 1 years plus beta sub 2 years, and so, well, beta sub 1 plus beta sub 2 times years. So you have a different slope. So I think you can imagine that that would be something that would be very easy to believe that, oh no, actually I think we have a slope dummy here, and we need a slope dummy and not an intercept dummy. And of course you can do both, all right? In fact, that's what he shows in the book. Here on figure 7.5, he shows one that has both a slope dummy and an intercept dummy. So not only are they starting at a different point, but also the rate of increase of your salary, I don't remember what he used as his example, but the rate of increase of salary is faster if you're male than if you're female, so you could do both. So anyway, that's really handy, that's really useful, that's something that you might actually use. And you have to ask yourself, do I believe it looks like this? Or do I believe it's like this? Or do I think it's some each? And this is one of those cases where you could justify theoretically trying it this way, trying it this way, and trying it both ways. Just report all of them, all right? But you're like, you know, I couldn't make up my mind. Theoretically, I believe being a female hurts your salary. But I couldn't make up my mind how, because I thought that it was theoretically justified that it could be any one of these, all right? So anyway, that's the end of that chapter. Some more really neat stuff. Chapter 7.